For that, because this is a common variable which can be manipulated by two threads, both of the two odd and even threads. So that's why we have to mark it into we have to use a lock here. So I will use a lock. So here I will just use try first, and inside this I will, but the lock that you created, we have to lock it because we are going to manipulate this turn. And then I have to toggle this turn, and for that I can use this XOR operator. XOR is like this, and it should be true. So for example, if turn is true already, then it will, by using this XOR operator, it will convert it to false. And if it is like false, then it will be false XOR true is true, so it will become true. So this is the way. I mean, whatever the previous value of turn was there, after using this operation, it will change to the other value. If it was false, it will become true, and if it was true, it will become false. And then finally, what I will do is that this toggle turn condition is that we have to signal that it has been already converted, or it has already been toggled. Once this is done, I will unlock it. So let's revise what we have done so far. So for toggle turn, the main purpose of this toggle turn is that we have to change the turn. If the turn was true, it will be converted into false, and vice versa. This is what we are using here in our odd even thread, that once a thread has got entered to this statement, if it is an odd thread, then the turn will be converted so that the even thread can get a chance, and vice versa. If the even thread has implemented it, has printed this statement, then the monitor toggle turn will change the turn to give the chance to the odd thread. And this is what we are going to do here in this wait turn, because we are passing this is odd parameter. Let's go here again and let's implement this wait turn. Again, we are going to manipulate this common Boolean variable, which is manipulated by two threads. So that's why we have to protect it by using the lock. So again, I'm going to use the same try lock. So I will use try, and then I will do lock.lock. And now we enter the critical section. Now what I will do is that I will need to check that while the turn is not equal to is odd. Or we can change this to like some other name, maybe it would be more evident. So it's say odd turn. Or maybe it should be old turn. Sorry. Old turn, okay. If turn is not equal to old turn, then in that case, we have to use this condition and wait here. Await, okay, because await will be throwing interrupter exception, so I will catch it here. Final interrupted exception. Just make as E, and E dot say just have a print stack trace, and finally I will unlock it. Now let's revise what we have done. Now what it is showing that once we call this wait turn, and we are passing this old turn as well. For example, here we are passing whether it was an odd thread or even thread. So let's example whether it was an odd, okay, and so it means that it is true. And the first time it will go here, it will see that whether this is true. And it will try to see whether so our first, when we start this program, our turn value is true, okay, because turn is true. So this statement will not hold true, because both true and it's not equal to true. So it means that it will not execute, it will not call this await method here for the odd thread for the first time, and simply just unlock it and go back here. So this will not have any effect for the first odd thread. And then the odd thread will print the statement I is equal to 1, and then print this name. And then we again call the toggle turn. So toggle turn will go here, and it will change this turn value from true to false, and then it will signal all. So signal all will have no effect for the first time because there is no thread been awaiting here. But in case if this was now next, say suppose even thread gets a chance and it enters here, and it will have this false, and it goes to wait turn. This is false right now, and this is also false because we have toggled the turn. And once it has got false here, it means that it will also not go here inside this, and it will not await, and then it will print the statement without waiting here, and it will print I equal to 2 and then proceed further, and then again toggle the turn. So if you do the toggle turn here, again it will change from false to true again, and then it will signal all. Again, there will be no signal all as such. Now just see, this is the good scenario which will happen when the odd thread comes first and then even thread comes first, and everything goes smooth. But what happens is that because the threads can run at whatever time, it depends on all the CPU scheduler. In that scenario, suppose there is a condition. Say here in this even thread, I mean the scheduler has got given this even thread chance first, and it starts executing before odd thread. So let's see what will happen. So when even thread has started first, it will start with I equal to 2. It will go here in this statement, in this for loop, and here it will pass as wait turn is false, because its odd is false here, so it will go here with a false statement here. So this thread, the even thread which is entered for the first time, it will get a lock, and then it will check this condition. Now this condition true, it was initially true, and this old turn which is for the even thread would be false, so it is not equal. So this condition will hold true, and that's why the even thread has to wait here, and it will keep on waiting here until it receives the signal all method. Now in this scenario, now even thread has been waiting now for the first time. Now the odd thread gets a chance to run. It starts with I equal to 1, and then it goes here in wait turn. So in wait turn, it sees that the turn is true and old turn is also true for the odd thread. So it doesn't go inside this condition, and it immediately releases this lock and moves out. And then it prints the statement I equal to 1 for the first time, and then it calls toggle turn, and in toggle turn it changes from this turn from true to false. And once it runs it, now it signals all. So the signal all is important here, because this await and signal are the conditions where how the odd thread and even thread are coordinating with each other. So once odd thread is done with writing, it calls this turns, it changes this turn to false, and it will signal all, which means that the even thread which has been waiting initially on this await method, it will get a signal to awaken up and then proceed further. And then both the threads are moved out of. So odd thread will move out of toggle turn. It will release this lock after signaling this thread, this condition. And similarly, the even thread which was awaiting here, it will also release this lock and go back. And now even thread has got a chance to run, because as soon as this moves out of this wait turn, the even thread will print this statement I equal to 2, and then it will proceed further, and then again it will toggle the turn. So this is the way this wait turn and toggle turn, these are the most important the method implementation that we have done, which is based on this condition whether we should toggle the turn or not. So every time it would be one thread which would be awaiting here, and the other thread which would be printing the statement, and then it will call this toggle turn method to signal all, so that the awaiting thread would be released here. So this is the whole mechanism. So once since we have implemented it, let's try to run this, whether it's giving the correct output or not. So let me run this test case now. So we expect that odd thread should be printing first and then even thread. Okay, so thread has, the output is shown here. So as expected, I equal to 1 is printed by odd thread, then I equal to 2 by even thread, and on until it goes down to 100. And for even so I equal to 900, I equal to 100 is even thread. This is all expected, and which is given in our problem statement. So let's revise again what we have done. Okay. So we have created this created a new monitor and passed it in both the threads as a parameter, and we have got this Boolean flag which indicates whether it's a odd thread or even thread. And then we started these two threads and joined it until this test case finishes. This is important to join because we have to print everything which is inside this odd thread and even thread run methods. And let's go back here. So here we have created this monitor and this sort as discussed. And when this is the most important part about any thread that how we implement this run. So for the odd thread, it will start with I equal to 1. For even, it will start with 2. And then we have a for loop for iterating till 100. And in this I plus equal to 2, we have this because we have to increment by 2 because both even and odd threads will execute their numbers in this statement. And this is where we are doing this thread coordination by using wait turn and toggle turn. And whatever threads executes, it will print this number with its current thread name, and then proceed further. For the wait turn, as discussed, that it will any thread which will be using this old turn. If the old turn is not equal to this turn, which the variable which we are maintaining in this monitor, if it's not equal to old turn, it means that it has to await. And so it means that if the odd thread has run previously, then the even thread will proceed now. If the odd thread gets the chance again by the scheduler, it has to wait, because in that case because whatever thread has executed this toggle turn, it would have changed that turn variable. So in that case, no, the same thread, whether it's odd or even, it cannot execute 2 times. This is where this toggling condition comes, and this is maintained by just creating a very simple Boolean variable and toggling it every time a thread writes it, and then call this toggle turn. So again, just go through this line. I just go through this code again and try to understand first. So we are simply using a wait or notify all condition, and here we are using the more advanced one to use condition variable instead of using simple wait and notify all. But the idea is exactly same. We are just using one condition, which is the toggling condition, and we are waiting and signaling all based on that by just calling before this wait turn, before printing this statement, and after we just toggle it. So this is all about this code and all about this problem. So in the next video, we will see implement problem number 6, where we will implement Unix tail command in Java. So the tail will be done on a static file and tail on a running file, appended in real time. So this is our next problem statement, which we will cover in our next videos. So stay tuned for the next videos.